Hello, I am Mr. Rogers, and you are watching the video notes for Section 2-2. This is on electricity, and Section 2-2 is covering electric charges and current here. So now in the previous lesson, we talked about static electricity, where those charges would build up on an object. And so this series of notes is all about moving electrons, or creating electricity that moves through a current, moves through a circuit, excuse me. So, and again, thinking about that, we're talking about moving electrons or moving electricity, moving through a circuit. And to do that, we got to kind of take a step back and think about, what causes electricity to move through a circuit. And it goes back to an idea known as potential energy. And potential energy is energy that's dependent on position. So, where you're located. The great example of this would be a roller coaster. You have the most potential energy when you're at the top of that first hill on a roller coaster. Right before you start to go down, that's when you have the highest potential to go the fastest. Now, in terms of electricity, we call that electrical potential, And electric potential is the potential energy per unit of electric charge. So this is the idea of how much charge is passing a certain point at a certain time and how fast. And this goes into the idea of potential difference. It's kind of like that top of the roller coaster and the bottom of the roller coaster analogy. So potential difference is the difference in electric potential between two places. So think about a circuit or on a battery. We've made circuits before. You have the positive end, the negative end. It's that potential difference between electrons moving between those two terminals that creates our electric flow. And so what happens here through a circuit is electrons tend to move from high to low potential. So high to low, always going high to low potential. And I do have kind of an example to help you out with this. What we have here are two drawings. The first one here, I'm trying to make that roller coaster analogy. So if this was the top of the hill and here's the bottom, would this be like the wire connecting? And right now the switch is open, so it's not turned on. Maybe the light switch is turned off right now. And so this side, electrical potential, all of our power sources up here, the charges are at rest, they're not moving right now. And what happens is, the second picture got a little more blurry. When you open that switch, we complete it, we say it's closed, we complete it, so the path is completed. Now these electrons or these particles can flow, and here's that hill. And electricity, the idea of potential difference is, the greater the difference between the top and the bottom here would be an example like the roller coaster. So the higher the mountain, or higher the hill, the more potential there is for those electrons to flow down the hill. And that's the idea of electric current, are these particles flowing, moving down from high to low potential. Okay, so moving back here, what this means in terms of electricity. How do we measure that potential, moving from high to low, from top of the hill to the bottom of the hill? How do we measure that? That is measured in something called voltage, or volts. And voltage is a unit of measure of potential difference. Voltage causes current to flow through an electric circuit. So voltage is what you need to make that electricity flow. All of our batteries have a certain voltage that we use in class so far. Your home has a certain voltage or certain voltages and everything. That's what causes electricity to flow through a circuit. Now, voltage sources create potential difference in electric circuits. So our battery in our circuits we've made creates that potential difference in electric circuits. So batteries, generators, power plants. So they have two terminals, and the potential difference between them causes the charges to flow. So when a battery is brand new, there's a lot of potential difference between the positive and the negative. As that battery is used up, those charges balance out, or that hill basically shrinks back down to there's no hill, and so now the electrons cannot flow. So the greater that difference in potential, the higher the voltage is going to be. So an increase in voltage, like I was saying, causes a greater flow of electric current. You think of electric current just like you would water flowing. We'll make that analogy here in a minute also. So think of a waterfall. The higher the waterfall, the greater speed that water can pick up as it falls. Now, the greater the resistance on the opposite side, the less current there is for a given voltage. And we've talked a little bit about this here in terms of what causes electricity to flow is that the voltage running through the wire, the circuit. And there's always resistance, there's always things slowing down the flow of electricity, whether it be other light bulbs or resistors that you add. Even just the metal you use itself has some resistance, so it's always slowing down. And if you add more and more resistance to a circuit, you're going to have less and less current or water moving through. We can make that analogy here for a reason. So now resistance in a circuit, things that would slow down the flow of electrons, depends on a couple of things. Depends on the thickness of the wire, the type, if it's copper, other iron or metal alloys, it depends. Those all affect how electrons will flow through. And also the length of wire. The longer the wire, the more resistance there's going to be. So the final note here is electricity always takes the path of least resistance. And to think about this in terms of resistance and how current flows, using that water analogy. I picture don't worry about most of the writing, I kind of got blurred in here. I want to make a water analogy between water flowing through a pump and pipes and a circuit with a battery, wire. We have a resistor here, they make a light bulb, and the path back to the battery. So if we compare our electric circuit to our water pump over here, we have our battery, which is going to produce that potential difference, produce that voltage. That'd be like our pump. So the bigger, the more powerful the pump, the more water it can push through. The bigger, the more powerful a battery, the more electricity it can push through. And so right here out of the gate, this is when there's the highest pressure, or this will also be the highest voltage is coming out of the circuit. And this is in a direct current moving directly from one end to the other. So you have that force, that water being pushed through. And over here we have electrons being pushed through our wire, like our water being pushed through the pipe. What happens is, as that water gets to like our resistor, this will be our light bulb, you can see where it's really narrowed down. So resistance kind of slows down or interferes with the flow of the water. Or in this case, interferes the flow of electricity where it restricts the flow. It slows it down, makes it harder for it to pass through. And that water would continue on back to the pump. And same over here, the electrons would continue back toward the pump. And over here on our pump, after it's kind of slowed down here, on this second half of the circuit, there'd be far less pressure because this bottleneck happening right here. And same is true in our circuit. As it goes through a resistor, and this slows down or interferes with the electrons and how fast they can move. So it means this back half of the circuit, the electrons are moving much slower, and there's less voltage or current moving through the wire. So when you think of electric current, think of it like water moving through a pipe. If you have a bigger wire, or if you have a bigger pipe for water, more water can flow. If you have a more powerful battery or more powerful pump, you can push more water or push more current through. And I want to make that one quick analogy between our electric circuit and our water pump over here. So these are our quick kind of basic notes on electric current and how it flows and why it flows. And we'll do more of this in class later on. Thank you guys for watching.